Mutations, explained by Pete the Puppy, by Lily Edmondson. Here's our amino acid sequence for a protein 5 amino acids long. First, we are going to find our coding strand and our template strand. Since we know that this sequence is going to code for a protein that's 5 amino acids long, we're going to look for a start codon, AUG, because T's are transcribed into U's in mRNA, and then a stop codon 5 codons down from the start codon. So looking at the top strand from 5' to 3', we can see a start codon, but the stop codon is only 4 codons away, so that protein would be too short. Looking at the bottom strand from 5' to 3', we find a start codon with the stop codon UAA 5 codons away. This means that the bottom strand is our coding strand, and the top strand will be our template strand. Now I will rewrite only the coding strand in the 5' to 3' orientation for clarity. Through transcription, the coding strand thymines will all be transcribed into uracils in mRNA. In translation, the mRNA will be translated into amino acids using our amino acid codon chart. Now we will look at 4 examples of different point mutations that can occur, starting with a missense mutation. A missense mutation occurs when one base pair is changed, resulting in a different amino acid in the protein product. In this example, we will mutate the 4th amino acid guanine into a cytosine in the normal coding strand. This will create an mRNA product that is CUC instead of GUC. CUC codes for leucine instead of valine, changing one of the 5 amino acids in our protein. This is an example of a transversion because G is a purine and C is a pyrimidine. Now we will look at a nonsense mutation. A nonsense mutation is a mutation where the mutated base pair causes the amino acid to become a premature stop codon. In this example, we will mutate the 13th amino acid adenine into a thymine in the normal coding strand. This will create an mRNA product that is UAG instead of AAG. UAG codes for a stop codon instead of lysine, prematurely ending our sequence, leading to a shorter protein. This is an example of a transversion because A is a purine and T is a pyrimidine. Now we will look at a silent mutation. A silent mutation is when the mutated base pair does not change the amino acid in the protein product. In this example, we will mutate the 9th amino acid guanine into an adenine in the normal coding strand. This will create an mRNA product that is AGA instead of AGG. Even though a base is mutated, this does not affect the protein product, as both AGA and AGG code for arginine. This is an example of a transition because both A and G are purines. Now we will look at a read-through mutation, in which the base mutation converts a stop codon into the codon of an amino acid. In this example, we will mutate the 16th amino acid thymine into a guanine in the normal coding strand. This will create an mRNA product that is GAA instead of UAA. This will cause the stop codon to code for glutamate. This is a transversion because thymine is a pyrimidine and guanine is a purine. The end.